Welcome to Lego Academy. In this video, we're going to handle questions under matrices. And here the statement says, given that matrix A is equal to 5, 1, 2, 0, and B is equal to -1, 0, 0, -1. Find Roman numeral 1, the inverse of matrix A. Now, to find the inverse of matrix A, we need to find the determinant. So finding the determinant, so matrix A is equal to, so here we have 5, 1, 2, 0. So when finding the determinant, we are going to subtract this minor diagonal from the major diagonal. So this will be determinant of A is equal to 5 multiplied by 0 minus 2 multiplied by 1. So 5 multiplied by 0, this is 0. 2 multiplied by 1, it will give us a 2. So here we have a minus, we maintain the sign. 0 minus 2, this will be -2. So this becomes the determinant. Now that we have the determinant, we can proceed to find the inverse of A. So inverse of A is equal to, this will be 1 over this determinant here, which is -2, multiplied by the adjoint of matrix A. So to find the adjoint, the major diagonal, the numbers in the major diagonal, they are going to swap. This 5, it is going to be here, and this 0, it is going to be here. So where there is 5, we are going to put a 0, and where there is 0, we are going to put a 5. The numbers in the minor diagonal, we are going to multiply them by a negative. So negative multiplied by 2, this will be -2. Negative multiplied by 1, this will be -1. So we can multiply this with everything inside here. So 1 over -2 multiplied by 0, this is 0. 1 over -2 multiplied by -2, this will be -2 over -2. 1 over -2 multiplied by -1, this will be -1 over -2. 1 over -2 multiplied by 5, this will be 5 over -2. So this can be simplified. Here we have a 0. -2 into -2, this is +1. Here we have negative, and here down we have a negative. So negative and negative, they'll cancel. We are going to remain with a half. So this one, we can leave it the way it is, since 2 leaves a remainder into 5. So this is our inverse. The next question, Roman numeral 2, 3a minus b. So 3a minus b, Roman numeral 2, we have 3a minus b. This means that we have to multiply this 3 by the matrix of A. So this is going to be 3 multiplied by, here we have 5, 1, 2, and a 0, minus the matrix for B, which is this one, -1, 0, 0, -1. So on this part here, 3 multiplied by 5, this is 15. 3 multiplied by 1, this is 3. 3 multiplied by 2, this is a 6. 3 multiplied by 0, this is a 0. Minus, here we have negative 1, 0, 0, negative 1. Now we can subtract the matrices. 15 minus negative 1. So here we have a negative and there we have a negative. So negative multiplied by negative, it will be positive. 15 plus 1, this will be a 16. 6 minus 0, this will be a 6. 3 minus 0, this is a 3. 0 minus negative 1, so negative and negative, that is a positive. So this one, it will be positive 1. So this is our answer for Roman numeral 2. The other question here, find AB. So to find AB, we are making A and B as a single matrix. So the matrix for A, we have 5, 1, 2, 0. And the matrix for B, we have negative 1, 0, 0, negative 1. So AB, it means that we have to multiply the matrices. Now when multiplying the matrices, we multiply row by column. So this is going to be 5 multiplied by negative 1, this is negative 5. 2 multiplied by 0, it will give us a 0, plus 0. When we move to the next column, we leave a space here. So 5 multiplied by 0, this is a 0, plus 2 multiplied by negative 2, this is negative 2. 1 multiplied by negative 1, this is negative 1. 0 multiplied by 0, this is a 0. 1 multiplied by 0, this is a 0, plus 0 multiplied by negative 1, this is also a 0. Negative 5 plus 0, this is going to give us negative 5. Negative 1 plus 0, this is negative 1. So here we have a negative, so 0 plus negative 2, positive multiplied by negative, this will be negative 2. So 0 plus 0, this is a 0. So this becomes our final answer. This is how we handle matrices.